This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hello everyone, this is Software Engineering Radio with Felienne today. With me on the show is Ken Youens-Clark. He's a data engineer at the Critical Path Institute in Tucson, Arizona, working on the Rare Diseases Initiative. Ken has a bachelor's degree in English literature and started to work as a programmer right after college, first learning Visual Basic on Windows 3.1. After working in several industry jobs, Ken spent 13 years at the Plant Genomics Project in Cold Spring Harbor Laboratory. In 2014, he joined Dr. Bonnie Hurwitz at the University of Arizona. He completed a master's degree in biosystems engineering in 2019, and Ken has just published his first book, Tiny Python Projects, in 2020. And Ken's book is going to be the topic of the show today. Welcome to the show, Ken.
Oh, thank you so much, Felienne. I very much appreciate you having me here.
Great. So the first thing, of course, I'm very curious about is why a book on Python? There are so many programming languages out there. Why do you think Python is the best choice to learn programming in 2020?
Well, the book really grew out of trying to teach biologists some basic programming skills at the University of Arizona. And this really goes back to my experience at Cold Spring Harbor working with Dr. Lincoln Stein. He started a programming course for biologists, and at the time, he started it in late 90s and early 2000s. He was teaching in Perl, and which was exactly actually why I went to work for him. So it was really about trying to get some sort of a programming language into the hands of biologists so that they could learn how to process the data that they were using. And Bonnie and I met in the lab of Lincoln Hurwitz. Bonnie and I met in Dr. Lincoln Stein's lab. And so when we came to the University of Arizona and started the Hurwitz lab, we also wanted to have that same kind of a class to teach biologists how to do some basic programming. And so we started off with Perl, 2015. And even in 2015, Perl was really on the downside as far as its popularity in our field, and Python was really rising, especially with the ascendancy of things like machine learning and NumPy and so many great modules. So after a year or so of teaching Perl, I convinced Dr. Hurwitz that we should switch over to teaching Python just because it's so widely used in scientific computing. And it has so much to offer for the students. And so we just kind of converted our materials, the same kinds of examples, over into Python. And then I just kept writing more and more examples. So in the classroom, I kept trying to find examples that I thought really helped to teach the language. And that's where this material came from. I'm not necessarily convinced that Python is the best language to learn, maybe as a beginner. I think it has a lot of advantages, but specifically we were trying to teach some basic programming to, scientific computing skills to undergraduates and graduate students.
So to summarize, I think what you said is Python is a very popular language, and it also has very good properties because it's meant for data science, for machine learning, for scientific computing, and not just Python itself, but the libraries and the ecosystem around it make it very good for data science-y type of applications. Is that right?
I would definitely agree with all of that, yes.
And you also mentioned that Python has some advantages. So I want to dive into that a little bit deeper. What do you think are some of the language features that Python has that makes it so good for a novice programmer?
Well, making the transition from Perl, say, to Python, which I did myself too, just kind of made myself become a Python programmer. And Perl uses the sigils in front of variables. So, a $sign or an @ %sign to help identify the different types of variables that you're working with. And I think a lot of people find that kind of syntax very confusing. I kind of relate it to like Hungarian notation that I learned in maybe the late 90s, where you put like str in front of a variable name to help you remember that that's a string, or I in front of the, at the beginning, like I num, to remind you that that's an integer. And so I think it's to me, that was useful in Perl, but I think a lot of people found it confusing. Some people do like braces to delineate blocks, but Python uses white space. And so Some people find the lack of braces and the forcing of indentation to make Python more readable. I think that's it probably is. I still see students produce very, very unreadable code, even with those white space requirements. But more than anything, I really think the REPL, the read, evaluate, print loop that Python offers is a fantastic learning tool. So it's something I really encourage in class, that when we're trying to understand like how to pop an element off a list, we open up Python. We just type Python 3, and then we have this REPL, and then we create a list, and then we're able to look at that list to say, well, show me the list, and it shows this visual representation of something that looks like a list, and then we can say, pop a member off, and then we see that the list is now shorter. I think that kind of a interactive tool is really, really useful for teaching students. Beyond those things, there are lots of other tools, like the tools that there are for formatting code, like YAPF and Black, linting tools like Flake8 and PyLint, which I also cover in the book. I think those can really help a person figure out what's going wrong with their code, or just find ways to improve it. And really, I think the biggest thing, that it's maybe not a language feature, but there is this huge community around Python, and which includes a lot of documentation and just places to go where you can just Google for, I just teach the students, like, Python add element to a list. I mean, you just Google for that, you're going to find dozens and dozens of examples and answers from everywhere, from Reddit to Stack Overflow. There's so many books. It's those things, I think, just the community around Python also make it a very strong language, and make it easier to learn, because there are places and people to go to when you get stuck.
Yeah, I totally agree. I think the community of Python is definitely something that's not necessarily the language itself, but that makes Python a really nice language for learners. And also indeed the REPL and the fact that blocks are delineated by spaces and or tabs instead of brackets. I think also that's a nice thing that helps novices learn to program in a structured way, because it forces them to do things in a certain way. So those are some of the things that are really nice for beginners. Not all of our audience, of course, are beginners in Python. So I'm also curious to hear, what do you think are some of the more advanced, very exciting Python language features? Or it doesn't have to be a language feature. It can also, again, be broader in terms of the environment or the community. What are some of the exciting things for more advanced programmers to get out of Python?
I think the thing that I've been most excited about recently, and I think it started in Python 3.6, was the addition of type hinting. And so I saw, I think it was a C++ programmer, had a tweet like, the feeling in the C++ community is like, wouldn't our code be a lot cleaner if we could get rid of all these type annotations? And then it's kind of the opposite in the Python community, I think, is like, wouldn't our code be a lot cleaner if we could add all these type annotations? And I actually really, I've become more enamored of strictly typed languages over the last couple of years. And I actually have been really using the type hinting a lot more. I don't introduce it in Tiny Python projects until the very last chapter, as kind of a here's where you could go from here, and here's some of the things that you would get as benefits to using this new feature. But it's that combined with things like data classes and these structures called named tuples that act more like this struct in other languages. You can essentially create new types in Python, and then instead of passing around, say, a string, you could say, I'm passing in a phone number, or a social security number if you're programming in the United States, maybe. And so it allows you to more accurately describe the things that you're dealing with, and I think that has really made my Python code a lot more interesting and easier to check with tools like MyPy, which I really find to be quite a good tool. I was really influenced by my journey through probably about 15, 16 years of being a Perl programmer, really enamored of Larry Wall and his approach to Perl. He really felt like there should be kind of a baby Perl that you could learn that would work and that you could be productive in. And then as you got better with the language, you could start using things that were fancier and maybe more powerful. And I think Python really lends itself to that as well. So you don't need to start programming with type annotations. But after you get to that point where you're like, oh, I made this mistake in my code, if only there would have been a way for me to have caught that as, without it being a runtime exception, something that blows up when the program's running. And I think that when you can show someone like, oh, if we can describe our code this way, and then like in the book, I say, okay, let me introduce this error. Like I put quotes around true, so it's actually a string instead of a Boolean type. And if I run this tool, it'll actually see that I made that mistake. And that's a pretty easy mistake to make. And so I think that sort of this idea of like gradually typing your code, which is also something that they really brought into the idea of Perl 6, which is I think now called Raku, that everything starts off as an any type, but as you need, you can start describing things more clearly, like this is an int or this is a string. And so I think that those are things that could really take someone's maybe intermediate level Python to a whole other level if you start introducing types and really trying to explore tools like MyPy and seeing what it can do to improve the reliability of your code.
Yeah, I think that's a great addition. People, of course, think of Python as a dynamically typed language, which it is, but these optional typing features that are new in Python that people might not be aware of indeed can help you find errors more easily. I'm really interested also to hear like a more concrete example. You mentioned something like social security numbers, but you also said that using types has made your coding more interesting. So could you give an example of where adding types really added something to the code base?
Well, there was actually, it was a module that I just released last week. It's an idea I've been exploring. It's something I have to do so much is parsing CSV files, parsing, the export from an Excel spreadsheet. And especially in this one project that I just left, there was essentially a value that, some floating point value in each record. And a lot of the data I get is really, really messy. And there maybe that is encoded as some string to show that the value is missing. Or maybe it was encoded in a way that can't be converted to a floating point value. And so I kept having to solve the same problem with each different data set, and they all looked different because I was getting data from a dozen different places. And so I was trying to parse through each record and parse this and convert this floating point value, and then if I was able to create this idea of a record, this data point, then I could continue forward with loading that into a database or another CSV file. And I came up with a way of describing what a record should look like out of this any file, and I describe it with a type that I annotate and so it is a class that I'm using, and I make a point in the book that I pretty much avoid personally working and teaching object-oriented programming style, but in this instance I am creating a class based on a named tuple, which has this also side effect of giving me this read-only, this immutable data structure, and I can describe in the class that this thing has some sort of a variable name that is a string, but it also has a value that is a float, and I'm able to pass this into this module that I created that does the conversions for me. And if it's able to create that kind of a record, that kind of a shape, then it returns it to me. And if it's unable to do that, then it could throw an exception or it could do something else. But it allowed me to describe what I wanted at a higher level and solve a problem at a more abstract level because I was able to describe it using types rather than writing the same code for every single CSV file that I'm trying to parse. I hope that's a good example.
Yeah, I think that's a great example. I would like to hear a little bit more detail because you also said that you used named tuples and that gave you an immutable data structure. So not everyone in the audience might exactly understand everything that you said there. So could you explain maybe in a little bit more depth what named tuples are in Python and how they give you immutability?
Yeah, I find this really fascinating. It's definitely one of my favorite aspects of the language that I've been using over the last couple of years. So I'm very much influenced by my experience programming or trying to program in Haskell. I'll be honest, I've never actually been productive in Haskell, but I keep reading about it and I find it a fascinating language. There is a dialect of Haskell called Elm that I've used on a couple projects to create web user interfaces. So essentially, it's a subset of Haskell that compiles to JavaScript, which I find just fascinating. And so that's a purely functional programming language that I've been able to really wrap my head around and become familiar with. And one of the hallmarks of languages like that is that you essentially don't have variables. You have symbols that are attached to, functions or data structures, but you're not allowed to change these data structures. You have to create new data structures from old data structures. And when I first heard this, because going back, I do not have a computer science background. I've come from English literature and music, so I'm completely self-taught. And so, the idea that a variable is by definition not variable. I was like, well, then how do you get anything done in a language like this, And but then I started to see over and over again as I was forced into a language where you're not allowed to mutate any values, that you just keep creating new structures. I was like, oh, I see advantages to this kind of a programming approach, and also just where everything is just a function. There are no objects. There's no global state. There's no global, integer value that you can increment and stuff like that. And you're just like all of a sudden forced to encapsulate everything. And there's a lot of rigor to the language. And at first, that's really, really difficult and very constraining. But then after a while, I started to see how much the compiler was able to help me and keep me from making certain kinds of mistakes that I was always making. And so I wanted to kind of cargo cult those ideas into Python. And so in Python, we have lists. So strings, oddly, are immutable. You can't change a letter in a string. You have to set the variable equal to an entirely new string value. But lists are not. Lists are completely mutable. You can mutate any part of a string, reverse it, and all that kind of stuff right there in place. And so a tuple in Python is an immutable list. So it's essentially a list, and you have list access just the way you have normally, but you can't, say, pop an element out of a tuple. You can't reorder the elements. You can't change an element in place. And so a named tuple allows you to use that immutable data structure, but assign names to the slots instead of getting at the 0th element and the first element. You can say the 0th element is the name and the second element is, the person's age and things like that. And so you start getting this data access that really looks like an object, because it's going to be tuple dot name without the parentheses, because it's not a method call, it's a field in that data structure. And then, so named tuples give you essentially a data structure that looks like an object, that has a little bit, I think, nicer syntax for accessing the elements than a dictionary. But then when you add type hinting on top of that, you get an immutable object-like data structure that you can now pass around, and you have this guarantee from Python itself that no part of that object is going to be mutated accidentally by your code. And an example of when I would use that, for instance, is I always represent the arguments to my program as an args data structure. And the arguments are those are set in stone. Those came from the user at runtime, and I don't want at any point my code to accidentally modify some parameter that was given at runtime. So when I represent that as a named tuple, I get that guarantee in my code, and I just can kind of put that idea to rest. I know that's not going to happen. That data structure is not going to be accidentally mutated anywhere in my code. That's a lot, but hopefully does that make? I hope I explained that well.
Yeah, I think so. So if I may summarize, what I think you're saying is that some of the concepts of object orientation and some of the concepts of functional programming are useful, and new features in Python allow you to make use of some of these more functional style properties like immutability and some of the more OO-like features like typing to create a language that sort of has it all, that has the dynamic feel of Perl if you need it, but that also can help you make less mistakes by giving you types and giving you immutability where it makes sense. Is that sort of a summary of what you said?
Yeah, that's very good.
Thanks. Then now I want to move on to the topic of the show. I think we convinced everyone now that Python is a great language that's very versatile. So you decided to write a book on teaching people that have no prior programming experience Python. And I was wondering, what is the gap you're filling? Because there are many books already out there to teach people programming or to teach people Python. What is the specific aim of your book? Why do you think an extra book was still needed?
I think from my own experience of learning programming languages, and I've just keep learning them, and I find the field fascinating. One of the things that I stumble with when I'm trying to learn a language is just seeing a large enough example of a program, a full working program. So often I'll be like I remember when I was first learning Haskell, and it was just trying to show me like how a function works. And finally I wrapped my head around that, and I'm like, okay, great. Now how would I use this in a larger context? Like how would I write a program that I can run that reads in something like a list and then does this thing that you were showing me about lists in Haskell? How can I do that? And I just was stuck. I'm like, well, how do I write the program, right? I want more of context. And so that was, I think, the first thing. I just felt like so many programming books show you just a little bit of code. Like here's a list, but like how do you create a list in a program? And so I wanted to show that's like the second or third element in the book is it's called going on a picnic. And so you get some command line arguments, and they're a list. And if you get 1, you're supposed to show it like this, and if you get 2, you show it like this other thing. And so I just felt like showing people more context would be useful for learning Python, for learning any language. But really, I think the secret thing that I'm trying to sneak in, and it's maybe not too secret, is testing. I think that especially beginners are not taught testing. I think this is, and I know I wasn't at all. Like you mentioned in the intro, I learned Visual Basic back in like '96, and I would say the first 5-10 years of my programming experience, no one ever used test. I worked in a bunch of industry jobs. I worked, delivering commercial software, and there were no tests in sight. Testing just wasn't done. And then finally I started coming across testing. I was reading and I would see when I would compile programs, and I would see I'm supposed to run make test. And then, 10 minutes later, it's done with its test suite. And finally I was like, well, what's going on there with testing? And I started looking into it. I'm like, oh, if I started testing my software, it would be better. And then when I started teaching, I didn't have tests at first. I was just kind of doing it the way that I had always been taught. Like, here, we're going to write a program, and we're just going to look at it. And if it looks like it ran okay, then great, thumbs up. You did a great job. And then I found that if I introduce testing and I say, okay, now we have this thing over here that's going to run your program and tell you precisely, is it right or wrong? And if it's wrong, it's going to tell you exactly what's wrong. I found that actually was really useful. I think that testing seems like it's often going to be saved until later, until you're some sort of an advanced programmer, and then you'll learn it, or like maybe when you go to your first job in industry, you'll learn it. And I think that's exactly the wrong way to approach it. I think that I work with kids to help them learn bicycles. You never put a kid on a bicycle without a helmet. I mean, when I was growing up in the 70s, we didn't have car seats or helmets, but we know better now. We use helmets. And so there's no reason why not to teach someone programming, like from the beginning. Hey, you can test your program and you can make sure that it actually does what you think it does. And I think that that's probably the biggest reason why I wanted to write this book, is to give example after example of what it means to write a program against a test suite. And when you're done, you actually know that it works for some idea of some specification.
I really like this bicycle helmet example. Even though I live in a country where no one wears a helmet if they bike, I do get it. So it makes sense to have built-in safety. However, testing is also hard, and even professional programmers with decades of experience still struggle to come up with the right tests. And often they think their code is correct, but then once it's running, it turns out that they missed some sort of edge case. So, how do you concretely teach people to test if they're not really advanced programmers? Because some part of testing just comes with experience, like knowing, oh, I have to test an empty input, I have to test a really large input. These are things that also sort of come from having been bit in the ass by errors many times. How do you explain the value of testing to novices?
Your first point is exactly true. I just left a project that had been around for a year or so, mostly Python, written by some pretty experienced developers. Not a test in sight, not a single test. And so I was actually brought in to help create tests. And one of the first things I did was I would just run a program with no arguments, expecting to see like some sort of a usage or something like that in the test. I mean, the program actually just charged ahead with bad input and just created exceptions and stack traces. And I'm like, yeah, this is a problem. You really need to practice. You need to run your program. If it expects a file, you should give it something that's not a file and make sure that it detects those things. And I, it is difficult to teach people, especially beginners, testing. And so, my goal, and I've used this book in a class a couple times now that I've taught. Again, that's where this material came from. Mostly, what I'm hoping that you'll get by the end of the book is that tests can be written. I try to get the reader to write unit tests. The integration tests are quite a bit more difficult because you kind of have to understand like the command line a little bit. And that's what I'm really providing, especially up front, are these integration tests. So tests that will, to start off, you're supposed to create hello world. And it's supposed to be called hello.py. And so the first test is that you created a file called hello.py, right? And then it runs the program, and with like it's supposed to say hello universe instead of hello world, and it verifies that it does that. And I think just example after example, getting the reader to run that test suite, to look at the test output. I hope that after seeing, 22 examples of that they'll kind of see the utility of this. And I really stress that, around chapter 5, we start getting into file handling. And I say, okay, your program should expect a file that it's going to read. Just so you know, the test suite is going to give you something that's just garbage. It's going to give you a non-existent file for that value. And so I'm trying to teach you defensive programming. In the same way, I say, okay, this parameter to the program is going to be an integer. By the way, the test suite is going to give you a string for that. And your program is going to be responsible for detecting that that's not an integer value. And throughout the book, I'll say, okay, let's just peek under the hood of what's going on in this test program. And we start looking at a bit of the code, and I say, do you see here how I'm creating, this is the name of your program, and this is the name of this parameter, and here I'm passing a good value, and here I'm passing a bad value. And when I pass a bad value, I expect that the program should return, for instance, a non-zero exit value. I've tried to teach, the idea of a well-behaved program that should properly report its errors to the greater operating system. And so, even working on this project that I just left, where, again, written by professional software developers with perhaps decades of experience, trying to introduce the tests, and just like, I literally spent like a month or 6 weeks just like saying, here's an example of a test. Here's how we test. Here's what we should be doing. And finally, tests started to be written just as I was leaving the project. And so it is an enormously difficult thing to get across, even from the beginner to the experienced person. But I think that if you keep showing examples of how this leads to better, more reliable code, it really starts to show its utility, especially with the ideas of refactoring, which is, something I really talk about in the book a lot, because I don't just find one example, one way to solve something. There's one, this silly exercise called Apples and Bananas. As a children's song, I like to eat apples and bananas. And then you start saying, I like to eat apples and bananas and things like that. And so it's just teaching children these kind of vowel sounds. And so the idea in this is that you're supposed to replace all the vowels with one vowel. So given any input phrase. And so I show like 8 different ways to do that. And the whole point of the test suite is that I can write a simple solution that works and passes the test suite. And then I can say, okay, I have freedom now to explore and find other ways in the language that I can do the same thing. And I can always come back to the test suite and verify that my program still does what it's supposed to do. And it's instantaneous and painless to just say PyTest. And it just runs it. And there's just no effort at all required because I, as the author, have provided the test suite. But I hope that by the end of the book, that you realize, wow, there really is a lot more freedom by having this strict test in place that really verifies that my program does exactly what I think it does.
So in summary, what I think you said is you have to show novices lots of examples, lots of example test code. This is how test code looks like. So they get the hang of it, and also show specific situations in which tests really add value. For example, if you're refactoring, if you're modifying your code, then you can trust your tests to help you understand if the code is still working as intended. So giving examples and giving example scenarios where tests are really valuable, that's the way to get even beginners to experience testing.
Yes.
Then there's more in your book also, because the subtitle of your book is Learn Coding and Testing with Puzzles and Games. So I want to ask you many things about all of the individual parts of that. So testing, I think we've covered, and coding we've covered also, but then there's still puzzles and games. So what are puzzles? What type of puzzles does the book cover?
A lot of them are, so, in trying to create a program that you can teach something from, there, I was trying to get across maybe 3 or 4, maybe 5 skills in any one exercise. And I definitely wanted the programs to be 100 lines or fewer. Probably a lot of the programs, especially in the early part, are 70 lines or fewer. And that's pretty generous too, because I'm using a formatter that is, pretty vertical as far as the way it distributes code. So I had to choose examples that were really simple enough that I could fit into that few lines of code. And I also I wanted the cognitive load to be lower. So I didn't want to teach something really complex, like the goal of the program, and also the programming concepts that we're trying to learn are also really complex. So I was trying to keep things really simple. I, for instance, really like the ideas of cryptography, and chapter 4 introduces this idea of, it's called jump to 5. So given a string, find all the numbers in the string, and then encode the numbers by using this algorithm called jump to 5. So if you look at a standard keypad on a telephone, the 1 would jump to 5 to become a 9, and the 2 would jump to 5 to become an 8, and the 5 and the 0 then swap places with each other. And so that right there, I feel like there's a lot of interesting things to piece out, like how do you iterate over every character in a string? How do you identify something that is a number? Given a number, how do you change it to something else? Given something that's not a number, how do you just skip over it? So I think there's that's a kind of puzzle. It's also a kind of encryption and a way of encoding text, like a secret kind of, and I feel like that's kind of interesting. It also, by the way, comes from like a television show called The Wire, which was pretty popular in the United States a few years back, and so it has like there's an interesting backstory, I think, to it. So like that's a simple little puzzle, I think, that makes for an interesting chapter that I could write. Another one's not really a puzzle, but it's like an insult generator, I think. And I really wanted I wanted the book to be playful. In fact, my original title was Playful Python. I wanted the book to just be interesting and fun. And so there's an insult generator. And I'm also targeting, really, my oldest is 16, and he won't read my book, but he might one day. And but that's the age that I was hoping maybe even a middle schooler might find it funny and interesting enough. But Probably not. I have used this at the university level, and I think that these are simple enough to understand the idea of what the program is supposed to do, but still interesting enough to make you want to finish it. So it's, the insult generator uses a bunch of Shakespearean adjectives and nouns, and it teaches you about randomness and setting random seeds and taking random samples and then putting strings together and iterating over things and doing things a certain number of times. So there's a lot of things that you can teach in that silly example that doesn't do anything useful in the world, but what you end up with is something that you can now sit there and hurl insults at your sister or something, and that's funny to an extent. Maybe I think it's a little funny, and so I'm just trying to keep with simple things like Mad Libs. Do you have Mad Libs in your part of the world?
Yeah.
Okay, so that is an example where you could talk about regular expressions. And I think that's a really common thing that most people have encountered that idea. And so there's not a lot to teach there. And then tic-tac-toe is where I end. And I know that's not a groundbreaking to do tic-tac-toe, but I think that I show, for instance, a way to test. Like, if you're going to create a tic-tac-toe game, how do you ensure that it works correctly? And for a game that is actually interactive, where you have two players who are choosing things, that you can't test the whole game maybe like that in its interactive state, but you can break it down into units, into functions that can be tested. So you know that when this part of the program is run, I know it's going to run correctly. So those are the kind of games and puzzles that I was trying to target.
Ever dreamt of building an app that impacts the daily lives of hundreds of thousands of people? Well, now's your chance. Monday.com is a work OS that helps teams work together. They launched the Monday Apps Challenge to bring developers around the world together to build apps, and they're giving away $180,000 in prizes, including 3 Teslas. Check it out at monday.com/SERadio and start building now. That's monday.com/SERadio.
I think you partly already answered my next question. So I was going to ask you, what is it about puzzles and what is it about games that make them really good for teaching? And I think you answered that by saying that puzzles and games are fun and interesting, and they are a way to get people interested in coding and also to convey what the things are that coding can do for you. But I'm still also wondering about downsides. So are there any downsides about using games and puzzles as a context?
Well, I definitely saw, I follow a lot of things on Reddit, and somebody made this exact comment about, like, I'm sick of seeing everything about learning Python being about games. And I think specifically they were sharing some idea of like a class, for teaching object-oriented stuff in Python that was like a player, and like a player, maybe like some sort of a first-person shooter game. And they were like, can we please get away from every example being about games? And I don't actually play games like that. I've never been enamored of computer games and Doom and all those kinds of things. So I guess I was just thinking about like games that you could just like draw on a piece of paper, or that you would just kind of do in the car. And so, yeah, I mean, not everyone's interested in games. I was all in some of my examples that didn't make it into the book are like from board games, like Yahtzee, which is a dice game, or Scrabble, which is a tile-based game with letters. I'm personally interested in those kinds of algorithms, like, given 7 tiles and one other tile, what are all the possible words that I could spell? That was my Scrabble game. To me, that's very interesting. It may not be interesting to someone else. And so, I recognize that.
Do you think creating those games, so not necessarily the games per se, but the process of creating games and puzzles, is that a good representation of what a programming career is about?
Oh, certainly not. Yeah, I mean, but honestly, what I've done so much of my career would probably just be very boring to somebody at
Yeah.
to teach from the beginning. I mean, unfortunately, a lot of what I've done is like cleaning up input data files. So I get, again, going back to like a comma separated values input file, or an Excel spreadsheet that I get from a researcher, or I download as, the supplement to a paper, and I need to incorporate this data into some database I have. And so, like that right there has probably been 50% of my career, is building databases and loading them. And that's fairly advanced. I mean, and actually that's a book that I want to write one day. And but I don't think that you can. I certainly don't think I could take a teenager and convince them that this is really interesting and that you could make a really cool career out of cleaning data sets for scientists. But it's a really important part of the process of, if we're going to move knowledge forward, we need to have an accurate representation of it. We need to collate it and aggregate it and analyze it. And so, no, I mean, certainly gaming and these kinds of puzzles are not representative of really what I've done, but there are elements to each program that carry over directly into things that I do every day. And when I was using these examples for my class, I would teach a chapter. We would work over on a chapter on Tuesday, and then on the Thursday class, it would be applying that idea to something in genomics, something in our field. And then we would just spend the whole class on Thursday talking about like that more applied example. And I think that the step from these simple games to things that you would actually do in the real world, I try to make at the end of the chapter is kind of like a little going further idea. And I try to make a hint at like how you could use this in a larger context, in a more realistic context. And maybe I didn't always, really convey that as well as I should, but I think that's my answer.
Yeah, I totally think the answer makes sense. Like, you want to emphasize the cool parts of programming and the interesting parts of programming and sort of initially step over the things that might be boring or repetitive.
Yeah.
I'm just not sure. We don't always do that, right? If you teach your teenager to do some cooking, there are also boring parts. You have to wash your hands. You have to wait for water to boil. Not everything can be exciting all the time. So,
Yes.
so there probably is some sort of balance where we want to show them some boring parts. And maybe you could also say that focusing on the testing and focusing on the correctness sort of is also somewhat boring. It's probably less fun than creating something yourself. But there you err on the side of caution. You're like, this is so important. So we definitely want to show how to test code. So I just like an interesting brainstorm question. How much of the boring stuff do we want to show them to give them a sense of what programming is? And how much cool stuff do we want to give to also lure them in, so to say?
I think you just have to keep mixing the two together and layering them. Spoonful of sugar helps the medicine go down, right? So, and I bring in the testing in the very, very first example. Like, okay, we're going to write "Hello World." Here's the test to make sure that it writes that we actually print "Hello World," and you can't miss a single space or a comma, any piece of punctuation. It has to be perfect, and that push to perfection, yeah, that's boring. That's like, oh, come on, didn't I get it close enough? Well, no. I mean, close is not good enough most of the time, at least, when we're writing computer programs. And it might be in cooking. And I was working actually with my youngest this weekend in the kitchen. I was trying to get him to help him make a cake, and I'd set out 2 sticks of butter, and he was going to go, one was for the icing and one was for the cake, and he was about to throw both of them into the cake. And I was like, wait, stop. I was like, you need to read the directions. He's like, I did read the directions. It says to add the butter. I'm like, how much butter? He's like, it doesn't say. I'm like, it does say. I swear to you, it says add 1 stick of butter. And so, yeah, I mean, like after I had admonished him a couple times, like he was really getting down. My wife was like, hey, you're being a little hard on him. He's just going to leave. I'm like, you're right. I need to keep him focused on the fact that he's going to have a chocolate cake at the end of this exercise. And he did. He made it. And we got past, a couple rough things. But, at the end, I'm like, okay, you got to wash those pots. And I just laughed. Like, you're the cook. Like, this is part of cooking. So, yeah, I mean, you have to teach those. I mean, it's not that hard of a lesson. But, your program should be correct. I mean, it should. And we have ways of verifying that programs are correct. And that it's not that burdensome to make sure that we've actually written it correctly. And I think specifically working in the field of scientific computing, we have a utter, complete crisis of reproducibility. And I think what I've seen since I came to University of Arizona in 2014 and really got to work like really in academic research computing and really working more with graduate students and undergrads and postdocs and seeing how much of the burden of science falls on them. The PIs come up with the ideas for the experiments, and then it's these students' jobs, or these young professionals' jobs, to execute these experiments and to analyze these data sets. And often they're producing data sets that are quite large and extensive, and they need help, computing help, to analyze them, and the PIs don't have that. And everyone just seems to assume that people are going to just find out, they're going to figure out on their own how to write programs, and that these programs are actually going to be reproducible, so that when they're released as the supplement or the GitHub repository for paper, that other people are going to be able to download and use these programs. And most of the time they're not. They're really horribly written, and they barely work for the person who wrote them, and they're not going to work at all in a different computing environment. And so, just from a larger standpoint of what I'm trying to do in the world, I want to make computing reproducible. And if you're going to work in a dynamically, somewhat loosely typed language like Python, you're going to have to write tests. If you choose to work in a stricter language, testing may be less important. It's still going to be important. Especially just like given this input file, if I run my program, do I get this output file? I mean, you need to verify these things. And so those were some of the things that I was trying to do with, like, why is this important? And yes, we're trying to create cool things, but along the way, they have to be right.
Yeah, and I think this balance is even true for professional programmers. It's always nice to create things, and then you get excited and you get into the flow of programming, and you have to tell yourself, well, wait, I need to add some tests, or if everything is done, maybe I should be a responsible person and refactor this code so it's more readable. There's always this tension between creating things and then cleaning up after yourselves in programming, but also in other areas. So I guess some of the tension there is also just some decisions you made for the book.
Well, actually, if I could follow up on that.
Sure.
I think that, obviously I was writing this book and like putting my name on this. And so I was really trying to internalize these ideas and really trying to explore what is test-driven development. So of course that phrase comes from, I think it's 2002 book by Kent Beck. And the basic pedagogy is you have some feature that your program should do. And so you write a test that verifies that your software does not do that thing. You run this test, you see it fails. That's the first step. And then you go write the function or you implement the feature that fulfills that test, and then you run the test suite, and now you see it does hopefully pass your test suite. It's kind of the same thing. Like my wife and I joke that, like, once we had children, we had to start eating better, right? Like we kind of ate a lot of, store-bought junk and didn't really focus on a lot of fresh vegetables. And then all of a sudden you're this model for these young people, and you want them to grow up eating well and having good habits. So you have to model these things. And so, I started really pushing these ideas on myself. Like, okay, I need to write this function. And really it has come to dominate the way that I write, especially in Python, is that I write the test first. I think of the function that I want to exist, and I first go write, test underscore function, because I'm using PyTest, so it runs all the functions that start with test underscore. And I say, okay, this putative function is going to take a list, and it's going to return a string. So what happens when I give it an empty list? Okay, well, I would expect to get back an empty string. If I give it a list with one element, I expect to get back this string. So I actually write down examples so that I can see, if I give it this, I'm going to get back this. And then I go write the function. And I've been surprised how many times I misunderstood my own ideas. And it was only by virtue of having written that test that I realized that I didn't implement the function correctly. And I've been programming for like 24 years. I mean, and I've done a master's degree, and I've learned, a dozen different languages. And so I think I'm a pretty capable programmer, and I still make really, really dumb mistakes all the time. And it's only by virtue of forcing myself, and really not even forcing, this is how I think now. I can't write code without writing tests. And I think that has been a sea change in my mind. So the idea that I would come in later and write the test is completely backwards to me. the tests come first, and then I write the program that satisfies the test.
Yeah, that makes a lot of sense. I'm now just curious, like, was this a slow evolution in your thinking, or was there more like this big bang, this horrible one bug, sort of like the birth of your children that you describe was like, okay, from now on, I really have to do better. Is there a juicy story here, or was it just slowly you realizing that that was the way to do it?
It was really slowly realizing it. It was, I try to pride myself on not making the same mistake, the big same mistake twice in life, but I make a lot of the same small mistakes over and over again. And they were so painful, like they accrete in my life. And finally, I'm like, why am I doing this stupid thing? And so, it was really when I started releasing software on CPAN in Perl, the Comprehensive Perl Archive Network, and I finally came up with an idea that I wanted to share with the world, and I was really, really excited about it. And I'm pretty sure my first release had no tests. And then I started looking around. I'm like, oh no, tests are a part of what this community does. Like that's kind of an expected step that there should be this testing component to the software. And there was a few different testing harnesses and suites in Perl. And so, I just took the time to learn them. And I started learning about, code coverage. And I started thinking, well, can I get 100% code coverage, like in this small module that I've written? And I just really kept pushing myself, like, what can I do with testing? And then but it was only for stuff that I was releasing. It wasn't really for stuff that I was writing day to day. And I just kept realizing, especially as in again, modeling this behavior for students and teaching this in the classroom and trying to show the utility of this, and then starting to really try to make myself do it more, I realized this is actually really, really good. But the other big thing, and I anticipate you may ask, like, what are the things about Python that make it not so great for teaching? And so there are a lot of mistakes that you can make in Python that if you're not really, really aware of like how a lot of computer sciencey stuff works, you're just going to get a runtime exception. The program's just going to blow up. And so when I work in stricter languages like Elm or Rust, certain classes of bugs just don't exist for me because the program won't even compile if I have forgotten to handle some exception case. And in Python, that's not the case. The Python code will just compile. We talked about type hints, and they're really, really awesome, but Python itself completely ignores them. You have to use a separate tool to analyze your code to see if you're using the type hints correctly. Because if a function says it takes an integer and then at runtime it gets a string, Python doesn't care. It'll just keep running and create a runtime exception. And so what I just found was that when I started really adopting this test-driven idea when I'm writing Python code, my Python code is much, much better. And so finally just stop fighting it. Just do it the right way and your programs just end up working a lot better.
So we've covered Python now as a language, and I really like that you just thrown in some of the downsides of Python, which indeed was also something I wanted to ask about. So let's step away from Python as a language, and let's move on to how do you actually do Python if you're a beginner? Because of course, when we were learning to program, there wasn't something like an IDE. There wasn't an integrated development environment. You would typically type code in a text editor like thing and then run it on the command line. But programming has changed quite a lot. So how do you tell novices to deal with that? Do they install an IDE? Do you start with something like an IDE so that it can run tests and then maybe it can do refactoring? Is that something you also bring into the toolkit kids of novices, or do they first have to learn it sort of like we learned it the old school way in the command line? What is your pick and why?
I definitely think that IDEs can be extremely helpful to the beginner, and I do teach the command line in this book, and for like a Windows programmer, it is going to really require installing something like Windows Subsystem for Linux, which in and of itself is a barrier. And there's there's a payoff in that the programs that we create, I think, are really stripped down. I think that learning command line programming is really, really, in some ways, an ideal way to talk about things like a string or a file or a number, and to really just think about programming concepts. But there is a barrier to getting a command line environment. And actually, I really, our listeners won't know this, but you looked at some early text of the book, and you had a lot of really great feedback, and one of which was like, what if a person is on a computer and they can't install Python, and Python is not installed? Like, what are they going to do? Have you looked at something like Replit, REPL.IT, which is a website that provides basically an IDE in the browser and a command line environment for running these programs? And when I looked at it, my mind was blown. I was like, I had no idea this existed. And I can totally see the utility for this, because like one of the things that my wife has done over the years is like work with a lot of nonprofits, especially libraries. And in this small town in New Mexico where we were, the computers at the library were, for a lot of people, the only computer that they had in their life. And they would come in to check their email, do their taxes, watch videos, whatever it was. And, I'm specifically thinking about those kids that would sit down, had no computer at home, and wouldn't be able to install Python on the library computers. And so when I saw that, I was like, this is a total gateway drug to being able to do these sorts of things. And so when I'm teaching in class, I recommend that students install something like VS Code, which is a Microsoft tool, integrated development environment, or some of the editors like Sublime, and PyCharm is also an IDE, but some like an editor like Sublime or TextMate really have a lot of features that are almost like an IDE. So I think there are a lot of tools that would really help a person to write code. I stress a lot about going into the REPL and using the help documentation there, but IDEs can just right there in context show you, oh, this is a string, and you type the name of the variable dot, and it will start saying, oh, here are all the methods that belong to that class. And so those are things that could really help a beginner. And so I think that there's a multitude of tools that a beginner would probably really benefit from using, from web-based IDEs to ones that you can install on your own on your own computer. But there really is, like, just installing Python itself, if it's not already installed, and a lot of times it is, but if it's not already installed on the computer, that in and of itself is not a beginner task. So that could be a huge barrier. My kids, their first programming experience has been Scratch from MIT, the little cat. And so, and they're not really even typing that much, but they're being introduced to the ideas of variables and loops and things like that. And so I think that there are more things that we could do to make it easier for beginners to learn. It's certainly not easy, and the first couple weeks of class is really just trying to get my students some sort of environment where they can actually write and run code. I would say it takes about a month before they really start feeling comfortable with what they're doing.
And do you think that changes over time? So with testing, you take a strong stand. You say testing, you should learn it from the beginning because it's important. So for an IDE, would you also say it's important to use a very powerful tool from the beginning because it matters? Or would you say, as you are advancing as a programmer, your tools should also get more advanced?
I definitely think that you should be open to change. And I say that, although when I write code day to day, I'm still using Vim, which I learned in 1997. So I haven't changed. I write code exactly the same way that I've written it over my entire career. And I've had to use IDEs like when I was, programming in Delphi and things like that. But I always have come back to the command line. When I'm teaching in class, I use an IDE because I'm trying to model what I think my students should be doing. I think that's what's appropriate for them. And like, for instance, VS Code is the one that I've done all the videos with. Right there in the window is a command line. So you have your file browser on the left. You have whatever program you're working in on the right, and below that I have a little a little terminal, and I can just say, okay, go run the program and run the test suite, and then there are the results right there. And so I think it's a really useful tool. When I'm writing code for myself, I usually just have a couple terminal windows open.
So I think what you're saying, but correct me if I'm wrong here, is that your take is that IDEs are very valuable for beginners. So you use them in teaching and you use them in making videos for the book, but you yourself still prefer to program on the command line as a more advanced programmer.
I guess, and so much of it is muscle memory. If for your listeners who don't know VI, it has all these really cryptic key combinations, but my hands like never leave the home keys, right? I'm able to do everything that I want to do without the aid of a mouse and just by typing, and the commands are just so deeply embedded in my brain that I'm not sure I could write code as efficiently as I do if I were forced to use an IDE all day, every day. They're really useful tools, and I think everyone should do whatever is good for them, whatever works for them. And this is what works for me, and I think I'll just keep doing it until I die.
I also want to cover as like a final topic in this episode, the Python ecosystem, because all the way in the beginning of the episode, you said what I really like about Python is everything it brings, like libraries for data science and for machine learning. So I want to like loop that back to beginning programmers. Do you think teaching just vanilla Python is good for beginners, or do you also want to show them from the get-go, hey, Python has this super rich sea of modules? And I think there's one library, for example, in your book you do show learners regular expressions. So apparently there are some of these things that you think really add some flavor to Python. What do you think is the best way? Show a bit, show nothing, show many things? Does it depend on the audience?
I think, again, this goes back to the influence that I had when I went over to, say, working in Elm. And I think that I just got so focused on like, what can I do with the string? What can I do with the list? What can I do with something like a dictionary? And I found that the more I focused on understanding the fundamental data structures that are almost universal to pretty much any language, those kind of three things, strings, and then numbers, I guess, and then lists of dictionaries. I think really fundamentally understanding those basic data structures is key to working in any language. I do bring in regular expressions, I guess, because they've been such a cornerstone of what I have to do, especially when it comes to like cleaning up data sets. There's so many problems that can be described with a regular expression. And it's this whole other thing that I got introduced to really when I went into Perl, and then especially when I went into genomics, because so much of what we do is string manipulation and looking for patterns in text. And so I really felt like that was something that needed to be introduced. I almost never encounter, certainly not a novice programmer who's ever heard of regular expressions. And I think that that's like a power tool that you need to be made aware of really quickly, because you'll be able to use that so many times. And another module I bring in is CSV for parsing comma-separated files. But in talking to the editors in creating this book with Manning, they said, there's only so far you can take a person. So on a scale of 1 to 10, like 1 being a novice and 10 being like an expert, you're not going to take someone from a 1 or 2 to a 7 in the course of one book. That's too great of a leap. We really try to shoot for like a movement of 2 or 3 clicks. So, from a beginner to sort of around the cusp of an intermediate, maybe from an intermediate to something more close to an expert. And so I wanted to start basically from the beginning. I know that if somebody's never seen a function, never heard of a loop or variable, they would probably not be able to dive straight into my book. But I think, especially if you were coming from a language where you already basically knew these things and you just wanted to know how they were done in Python, like you were moving over from JavaScript or something, I think that I start at a good level, not too basic, and I think I move up quickly enough where you would be kept interested. And so I really do just want to focus on we start with Python strings, and then we talk about how they're similar to lists, and then we move into lists, and then we move into dictionaries, and then we move into file handling, and then we talk about standard in, standard out, standard error. Then we start talking about regular expressions. Then we start talking about like parsing files and making games and randomness, and so I think that there's a lot of things I guess I was just biased in what I wanted to cover. There is a huge ecosystem of things that Python can do, and I just really wanted to focus on the language itself. And definitely one of the early reviewers, he's a respected best-selling author. And he also said, well, you're just writing a vanilla Python book. Like why would somebody want another vanilla Python book? And I guess, the secret thing, the thing that I really want to sneak in under the covers is the testing. So Python is a cool language. It has a rich ecosystem, but more than anything, I want you to leave the book thinking, no matter what language I'm working in, I understand the basics of loops and these basic data structures, and I understand that software needs to be tested. And I understand a lot of the skills that I show in the book. You could write Python tests for a program that you write in any other language, because I'm just showing you how to run the program with different inputs and do you get the right outputs. And so I think those are the things that I really hope people will take away is how do you write reproducible, documented, really kind programs. Like, I really stress that it's our program's responsibility to show how they are intended to be used. And if you're using a module in Python like argparse, where you describe the arguments to your program, it can do all this data validation for you and also present the user a usage statement, like here's how I intend it to be used. And one of the other projects I was working on this over the last few months, entirely written in R. And not a single program out of dozens and dozens of programs, command line programs, not a single one uses a standard module in R for parsing command line arguments. Every single program did it manually. And so one of the first things I did was I was like, there's this really nice module over here called optparse. And you can describe all the inputs to your program and you can validate them. And you can, you would really erase a lot of bugs in this code base if you just simply validated your arguments first and then tried to use them later in the program. And it was no one was really ready to hear that yet. So I hope that by teaching vanilla Python, by teaching testing ideas, I'm teaching more universal ideas that you could apply to any language.
Yeah, so what your hope is that the things that people take away from the book, if they later go on to do R or Java or Perl or whatever other programming language, that some of the discipline that you showed them in testing transfers to other programming languages and other contexts as well.
Yes.
Great. So I think that's a great way to close it. Is there anything we missed on the show? Anything you still want to share with the audience?
No, I'm looking over my notes, and I guess there is one thing I would say in closing, and I was just having an exit interview with so today's my very first day at the Critical Path Institute. So on Friday I was having an exit interview with one of my PIs, principal investigator at the university, and I was trying to explain why I think, like, what is the good and bad about using Python, because he's pretty much settled on that for the project that he's working in. And I said, there's just this inherent complexity involved in writing software. And Python is great in one way because it kind of hides a lot of that complexity. It just you don't really have to think about how a string or an integer is represented in memory. You just create a variable. And if you put it in quotes, it's a string, and Python takes care of all that. And that's cool. But there comes a point at which programs become more and more complex just as they start dealing with more real-world concerns. Like you try to get some data from an API, from some sort of web resource, and it failed. And the way that it fails can just cause the whole program to just explode. It can create an exception, and if the exception isn't handled, then you get a stack trace, and you don't necessarily want your users to see that. And so I was trying to say that, look, there is complexity. It's just that Python pushes the complexity onto the programmer to handle. And other languages, like, say, Rust, force you, as you're writing the code, to deal with the complexity then and there. And the program won't even compile until you've taken account, well, what happens when we try to make this web API call and it fails? What are you going to do? You're not allowed to just disregard. Well, you are allowed to disregard it if you really want to, but you're making it explicit in the code. And so I think that we should definitely at some point really stress, especially to beginners, that if you're going to work in a language like Python, at some point your programs will become very, very complex, quite long. And without things like tests in place, you're really kind of flying by the seat of your pants. And so you need to understand that there is this complexity. You are going to have to deal with it. And yeah, I guess that's what I would close with.
Great. So we will definitely add a link to your book so that people can check it out if they're interested. And we also link to Replit, the web-based browser-based IDE for novices. Are there any other things you want to link to? Is there anywhere we can read more about the work that you do personally or the institute you just started working for?
Well, the Critical Path Institute is a nonprofit that's, you can find it at cpath.org. I'm really very interested to see what I'm going to be doing. I'm vaguely aware that I'm going to be working in like cleaning data sets and trying to find novel uses for existing drugs and maybe creating new drugs. And so if you're interested in that, you can find it at c-path.org. My website is kyclark.us, but as is typical, I rarely update it. I tweet every now and then. No, I would say we've covered everything. Thank you so much. I really appreciate your time.
Great. Thanks for being on the show today, Ken.
Thank you.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.